Okay, in this video, we'll make the project part jar handle. So that's the finished product, and we provided a partially finished part, which is this portion. Okay, so you can download this file from the web course, and as well as this sketch or the drawing. So basically, what you need to do is make the extrude for the jaw and make a swept for the grip. Okay. For the swept, all the dimensions is in the slides, and the position of the datums are approximate. So just eyeball it. Okay. And let's start with the extrude on the top. Okay. It's a little bit messy on the dimensions, so we have two views to spread them. And well, as usual, we're going to start with a sketch on XY plane. Alright, so as you can see, this is the finished portion. Don't worry about that. You're going to start from the origin. Profile, and let's take a look. We have, seems like a straight line going up and intersects with this line, 143 degrees, and there's a fillet at 0.36, then goes into an arc, a straight line, and straight line. Then you can add this piece later on. So I might start from the left side. So 1.87 is the total. Let's see, we can say 1.875. Then go straight up 0.21. Then go this way, which we do have an angle 123.31. So I don't know how long, but I know the angle. Well, maybe just drop it first. Then there's an arc, so that's not tangent. I'm not gonna use profile. I just use a arc tool and avoid tangent constraint. Then here we have two straight lines, and their corner is gonna be trimmed away using a fillet. Okay, so now we can add more constraint, more dimensions. Then just use infer dimension. This we have 1.875. Then straight up we have the height 0.31. Then this 0.56 is to this angle line. So we'll put this angle first, 123.31. Then the distance from that point to the bottom line is 0.56. Then we do have the top two curves not constrained, so this height is 0.4. Then from the end of the arc to the x-axis is 0.6. Then lastly, there's angle here 143. So we want degree here is 143, and let's see, the line seems really short now, so let's go back one step. So it seems like we made one dimension wrong. Yeah, so this one should be 0.4. That is 0.6, and the angle between them for dimension tool. .43. Okay. The last one is this arc on the top. The radius is 2.22, and as you can see, this is all constrained. Now we'll find this reference line 45 degrees. So there's line coming down here. We'll just overshoot. Okay, then we use infer dimension tool. 45 degrees, and the intersection point, we can trim this away first. Next step, we use infer dimension from this point to y-axis is 0.92. Okay, that's it for the reference line. So we'll turn that to reference. Then we can make this the binding parts, okay, for the jaw. And now this, we might need to look at this one. So first, let's find the starting point. It's 0.71 inch. Okay, so that's an arc, which is 0.71 inch away from y-axis, 0.71, and the other end is 0.155 or 1.55. So this might need to go a little bit lower, 1.55, and we'll drag this down a little bit. Okay, then the radius, 0.6 inch. Okay, then the top portion, so we can take a look at this view. So 0.3 from the left side, go straight up. We do have a fillet. Yeah, we do have a fillet there. Then on the other side, 0.03 going up straight line at 0.58 from the y-axis. So pretty much like this. It's going up. Then this goes profile tool is better that way, and going down a little bit, and going down a little bit, then touch the bottom. Okay, then we use the infer dimension tool. This height is 0.03, then the distance from this line to the origin or to the y-axis is 0.85. Then we have 32 degrees from this line to the bottom line. Okay, you could put it here also. Then the top line is 138 to this 32 degree. So between them, 138. And the last one from here seems like between those top two lines, it's almost 180, so 172 degrees. And between the left to this line is 0.03. Okay, and we're still missing something. It's the top portion here, 1 inch from this point to y, and also 1.44. So from here to again 0.44. And something's not right here. So let's see, 138 is between them, and 32, 45. Okay, this should be 32 here. So that's why. Okay, that's 32, not 38. All right, next here we have 2 round corners. You can do that using Edge Blend, or do it here in the sketch. All right, now I'll use Edge Blend. So my sketch is finished. Then how much I need to extrude? That's 0.56 symmetric for the bigger one. Then the smaller, the jaw portion is 0.69. Okay. Then we'll do extrude and extrude the bigger portion first. So I need region boundary curve. For this portion, I'll do a symmetric 0.28, which is half of 0.58, 0.56. So apply, then we can take a look. Then for the next portion, this portion is also symmetric, 0.69 divided by 2, and okay. And again, this head is tapered, so you want to build a datum on the reference curve. This way you can get a cut like this. So we need a datum plane, and we can just use invert and pick this, select this line, the end point of this line. It'll automatically give you a datum that's normal to this reference line. Now we'll say OK. So next step, we can draw a sketch on the datum. Once you pick the datum, your sketch origin will be far away. If you like to, you can move your origin to the end point of this reference line. That'll save you one reference because you have y-axis on the on the construction line in the first sketch. Okay, so let's go back normal to the sketch, and how sharp the taper is, what the degree is for the taper. So that's 10 degrees in total. That's 5 degrees each side, and this cut is, by the way, from here. Okay, cut normal to this reference line. So this way you can see the correct angle. And anyway, the angle for the top, or for the jaw portion, is 5 degrees down. So here, and the other portion is on the body, or on the big portion, and also touching the top edge. Goes down the same angle. We'll make this parallel. And also you want this line, the starting point of this line is aligned with your reference line, or the construction line in the first sketch, which is the vertical. It looks like a vertical line from this angle. Okay, so let's go back to the sketch view. And since we put the sketch coordinate system here, you can do a point on curve. Make this point to stay on y-axis. Just in case your sketch origin is not here, you can draw a vertical reference line up and put this point on the reference line. Okay, now we still needed to put the angle here, even though when we drew it, it's 5 degrees. Okay, so with the angle dimension is constrained, then we can just simply close the loop. And there's a little bit faster way I saw some people were using. You can do a 3-point arc, so you don't have to draw a rectangle. Okay, even though it looks funny. And finish sketch. Then the top one will be cutting the jaw portion. So we'll do extrude. Then this time we can pick select connected curve and pick this arc. And to make sure the extrusion will intersect, you want to have symmetric. Maybe not that long, but we can do subtract. Then pick this, do apply. If you want to take a look, and as you can see, the jaw portion is cut. Then the body or the bulk portion will extrude this and subtract for the big portion. Make it symmetric so it intersects fully. Then okay. Then we can hide this sketch and take a look. And that's the edge, which should be coincident if you look from the top with your reference line. Then remember, we only did the top portion. We can now mirror this to extrude to the bottom. So mirror feature is in associative copy and mirror feature. Then we need to mirror two features. Hold down Shift key and select both of the extrude. Then the symmetry plane is XY plane. So I used this before. That's the ZC icon, a symbol here. And that is done for the jaw portion. The next we'll build this the grip, and that dimension is in the slides. Okay. All right, now the swept for the grip, and it's pretty much the same exactly step on as the previous handle. So we have 4 datums. Okay, one of which is outside of your sketch, and for the first 3 datums, you can just eyeball it. I think, yeah, I don't remember where they are now. Just eyeball the datums. You can adjust later. You can adjust the datums after you make the swept. Then you will actually be able to see how the shape will change. Okay, and for the last one, we have that offset set to minus 0.3 away from the curve. So the datum is on curve. Then let's hide some stuff. Okay, we can hide the solid body. Then we can also hide this. Oh, by the way, we haven't united those 2 pieces yet, so we can do a unite for the jaw portion. Okay, just leave it. And I think I forgot to do the edge blend here. Okay, 0.03 for the edge blend. All right, now the sweep. The datum is on curve, so we'll pick on curve, and this is a curve. And as you can see, the first one is about the middle of your slot. So we'll just start from here. Get a maybe 4%, which is not good. Let's do 4.2% or 4.2 inch. Okay, that's on the arc length. So that is for one. Now we do a second one. Look from the top. Okay, that looks okay. Then we'll just give this a go. Then do the next one somewhere here. Okay, apply. And then for the last one, maybe you want to use percentage, so you'll get exactly to the end. But this way, see, this curve is 13 now. I just want this one curve here. So we'll bail first on curve, not tangent, use a single curve. So pick this curve, and we'll pick percentage. So this one will go to 0%. Okay, all the way to the end. Then the offset is minus 0.3. Okay, and the center really doesn't matter. Okay, 0.3, minus 3. Okay, minus 0.3. Then next page, the first sketch on the first datum. Alright, so we'll make a sketch on the first datum, and as you can see, my sketch origin is far away. It doesn't matter because we're gonna use the projected point or intersection point. So just to have a sense of where we are, I'll just draw from the 3D view here, and we have a rectangle which is 0.8 by 0.6 with some fillets. So we can just drop this anywhere. The width is 0.8. Typing, don't move like cursor. 0.6. Okay, and that's the size of your rectangle. Then we can drag it around. Then to find the exact position, first we might want to use a midpoint constraint, but before we do that, we should finish the fillet first. Otherwise, it's gonna delete our constraint. So 0.15 for the fillets. This point, this, and that. Okay, so that is done. We'll select this vertical line and select the origin point, which cannot be selected. So we'll just open this geometric constraint, pick the vertical line, pick a second item, and select origin. Okay, that's it. Then we have two intersection points, but actually if you take a look, the dimension is only on the left one, so you might not need to use this point on the right side. So anyway, let's get an intersection point for this curve. Okay, as you can see, we have one point there. We'll turn to black background, so that's the reference point, and we use infer dimension for this point to the vertical line on the left side, which is 0.25 inch, and now everything is constrained. Okay, so that's for the first sketch. So we can hide the first sketch, hide the first datum. Now we're doing the second datum. Okay, so on the second datum, we need to project the first curve from previous sketch, which is the one we just made. Okay, so this way you can align the right side within each different sketches. So we need to first create a sketch on the second datum. All right. Then second, we need to project. All right. Anyway, get that sketch from the other. Get that curve from the other sketch. Single curve. So you want to use single curve and select the curve. Now it'll be projected into this sketch, and you can tell from the color. Then we're done with the first sketch. Just close that. The next we'll do rectangle with fillets. So let's randomly drop this first. Width is 1 inch, height 0.75, and the fillet is 0.2 for all 4 corners. Finish. And since we have the fillets already done, we can apply the midpoint constraint for the vertical line to sketch origin. And also, that's why we needed the projected curve. We need to align the right side to that projected curve. Okay, and one thing is a better practice is to turn that projected curve into reference, because when you make a swept, it'll be multiple loop, or it'll be a line overlapping on another line. And sometimes it's NX is pretty picky on that, so it might be better idea to turn that to reference first, so that you know that's a reference. Then we make them collinear and finish. Now go to Datem 3. It's exactly the same as the first sketch, so this one is easier. We'll show the first sketch. Build a sketch on the third datum. Finish. And what we need to do is just project the whole sketch 15 onto our sketch. So if you click in the tree, it might be tricky because I think we selected the point as well. Let's try to deselect the point. Oh, it's not working. Then just reset. We'll do invert curves. Alright, it's not doing it. So let's try connected curve. Okay, so we won't pick other things in that sketch, just connected curve, this single loop. And let's say OK. Now we get the exact shape from that sketch. So that is all for Datem 3. For the last datum, it's getting a little bit smaller. Okay, and as you notice, this datum is a little bit different. My Z goes the other way, so that caused my Y to go down. So we'll change the normal. This way, my sketch, they all look the same to orientation. So here we do need to project or get this intersection point on the right side. So get an intersection point for this curve into our sketch and turn to reference. The one on the left side, it's not that important, or it's not used anyway. And you can get a rectangle, height, width 0.5, height is 0.6, and the fillet is 0.2 inch. Okay, finish. Then we can move this around, get a midpoint constraint on this line to sketch origin. So you want to move on the Y direction, then we have a distance from the reference line, the intersection point to the line on the right side, which is 0.0484 inch to this point. Alright, so this sketch is also fully constrained and finished, and we're good for the guide curve, right? We have 4 sections. Next is the guide curve, and it's pretty much the same as last time when you just connect those 4 sections, and looks like this one is an arc. So intersection for sketches. All right, this one is eyeballed as well. Then we'll just start from the top, then build a sketch, and this is on XY, so you can just simply build something like this. Now we'll first connect these sections, and the last one, maybe an arc is better. So what I will do is 3-point arc from here to here. I don't want tangent, I'll just eyeball it. Okay, if you want to constrain, just add a radius, constrain this arc. And also we want to make sure this is tangent, so we have tangent for this corner 0.07 and the 0.2. Now we can do 0.07 between these two, and 0.2 between that two. I think we didn't finish the second one. Okay, and apparently when I was drawing this line, it went to a different point. Okay, so you might want to zoom in when you draw this line. Over constraint, delete that. Then we probably delete that too. Delete that point. You don't have to fix that, by the way. So that was caused by this horizontal constraint. Now we'll make this line to stay on this point. Okay, so this way they intersect. Then that is all for this guide curve. And for the second guide curve, I will just use this arc from the handle. And now we go to the swept. Alright, so we'll pick sections, and depending on which line you want to use as origin curve, say if I pick the top line, so we'll pick the top line for the second section as well. This way they always align together. For the last one, you're going to be careful to pick the top short straight line as the origin curve. Then the guide curve, we need 2, so we're going to start from the left side. Turn to that. Apparently the right side is not very well. Then we need a second one. Add a new set, and don't use tangent, because everything's tangent on this sketch for the handle. You just need one single curve. So a single arc for this one, the right guide curve, and as you can see, it's much better. But if you look from the side, it's still a little bit sharp. You can change that to cubic, smooth things out a little bit, and okay. Alright, so we are almost done for this sweep. Then if you show the body that comes with the partially finished, we need to make it hollow, otherwise look, this is a little bit unrealistic. So what we do is we can first extrude this, the sketch that came with the part. Okay, and symmetric, the distance is 3/16 and 16. Then subtract from the swept. That'll make a hole there. And if you show the body, it's more believable. Then also there's a cut for the rubber piece, the grip as well. So the second extrude using this sketch that came with the parts. Okay, so the distance is 1/8, symmetric, and subtract from the grip as well. Now this will align your grip with the cut on the handle. Then we don't have any last step here. However, if you want to, you can use some edge blend to make the bottom of your sweep a little bit believable, and also on the top. Say OK, and we'll hide all the sketches in here, and also curves, and also Dayton. Finish. So that is the last part for the project, and we'll have another short video for assembly to assemble the whole thing together.